Back in late 2016 we shook the world when we announced the discovery of Proxima b. Now, 3.5 years later, we aim to shake it again with the announcement of a second planet in this system. Welcome to Proxima c.
Science violation. News flash.
Welcome to another news flash here at Science Violation with your host, Professor Jenkins. And first off, we would like to thank those first subscribers to our channel for their support. We are very grateful for that support and we hope that you enjoy future content we provide here at Science Violation. Today, we are going to discuss one of our old friends, the system Proxima Centauri. And why do we say it's an old friend? Because if you go check out one of the previous videos, discussions with Dr. Miko Tuomi, the link will be in the description below, you will get some background on why this is an important star system, being the closest star system to the Sun, and what makes it already relevant, the discovery of Proxima b. Well, now we are going to announce a second planet orbiting this star, a second small planet in the system. And what's special about this one is that it's very far from the host star. And given that the star is close to ourselves, this gives us real hope that in the near future we can directly image this small planet. So let's go on and discuss the system. So what makes Proxima Centauri so important? Why are planets orbiting this star that we discover so pivotal? Well, the star itself turns out to be the closest star to the Sun, with a distance of only 4.2 light years from us. It was discovered back in 1915 by the Scottish astronomer Robert Innes, and quickly we recognised that not only is it a single star, but that it orbits the bright binary of Alpha Centauri. That makes this a triple star system because Alpha Centauri, which is a naked eye star, you can go and observe it here with a naked eye. This is actually a double star, we thought originally, and now once Robert discovered Proxima Centauri, we realised it was actually a triple system. And recently, Pierre Kerveilla and collaborators found that the orbital period of Proxima Centauri around Alpha Centauri is about a little over 500,000 years or so. Now, the star itself is much smaller and fainter than the Sun. It has a physical size of about 15% that of our Sun, and that means its mass is around 12% of the Sun, 12% or so of the Sun. It's also been found to be what we call a flare star, and that means the star is very active, that we see a lot of these events, these flaring events, these brightenings, the effects of magnetic activity on the star. And this was discovered by the astronomer James Davenport using the MOST space telescope. So Proxima is much fainter than Alpha Centauri A and B in reality. You can't leave your house and observe it with the unaided eye. And given that it flares a lot, maybe you would think that it's not the best target to go searching for planets. And you would be right. However, given that it's the nearest star to ourselves, and now that we know there's at least 3 planets orbiting these type of small red dwarfs, these small M dwarfs that Proxima Centauri is part of, then this actually turns out to be one of the most important star systems to go studying. And of course, when we first observed the star with radial velocities, remember the radial velocity is this motion of the star away from us and towards us, given by the gravitational tug of a planet orbiting the star. Then when we did that, we found Proxima b, this habitable zone terrestrial planet, and now we've found a second on a much wider orbit, which we designate Proxima c, has an orbital period of about 1900 days. That means it takes about 1900 days to complete one Proxima c year, one orbit around the star. Now that means that the physical separation between the planet and Proxima Centauri is about 1.5 astronomical units, where an astronomical unit is the average Earth-Sun distance. The minimum mass of the planet is around 6 times that of the Earth, around 6 Earth masses. And remember, we must talk about minimum mass in this case because we use the radial velocity technique to discover the planet. And that means that this is another super-Earth orbiting Proxima Centauri. Now, what does this mean for future studies of the system? Well, what it means is, since this is the nearest star to the Sun, and the orbital period is such that the separation is quite large, in fact, physically on the sky, the angular separation is about 1 arc-second. Now that is important, that number is important to us because with current instrumentation we can reach much smaller angles on the sky, separations if you like, between a bright star and a faint orbiting companion. In fact, we can reach down to about 0.1 of an arc-second and find relatively faint companions. Now of course Proxima C will be much too faint for the instrumentation we have at the moment. But in the near future, when we have these real massive telescopes like the GMT, like the 40-meter ELT, then we believe that Proxima C will be a viable target, will be a real target that we can go after and directly image, given that it's so close and so widely separated from the star. And there we have it. The nearest star system to the Sun appears to be orbited not just by one planet, but probably two, at least two. It has a terrestrial planet orbiting in the liquid water habitable zone from the star, and then another in the cooler, colder, frigid regions much further from the star, a super-Earth. Something that we've been studying that turns out to be the most populous type of planet that exists in the galaxy. These super-Earths make up the highest fraction of planets that we observe, even though we have none here in the solar system. So what does these results mean for the origins of the solar system? For what we expect for systems orbiting small M-stars, the cool red dwarf stars? Well, we may be able to respond to those questions in much finer detail if the Breakthrough Starshot project is successful. Now, Breakthrough Starshot is a project set up and funded by the Russian entrepreneur and physicist Yuri Milner. And the aim here is to send a fleet of very small craft to the Proxima Centauri system and take images in situ of those planets orbiting the star. Now, if the technological hurdles can be overcome and we can traverse that huge distance between the Sun and Proxima Centauri, then I really hope I'm alive in that 40 or 50 year time scale when we get to see those first images in situ. That will be a day to behold, a day that changes the world. And so I think there's no better way to end this show than that. And I will say, remember, it only takes you to ask the right question to change the course of history. Good night.
Science violation.